everyone, I have some great news for you today. This is the last chapter of the year. Woo! I bet you're excited. And what's even more exciting is there's only 4 sections, so it'll go by pretty quick. Hopefully you've noticed that I've already put all the homework online and on Big Ideas, and it's up to you whether or not you want to do it before the lessons. Maybe you can figure some things out on your own, but I will be putting lessons on, so if you're not getting it, then here's your opportunity. Okay, so chapter 11, transformations, not like transformers. This will be different than transformers. Translations, reflections, rotations, congruence, and transformations. So today we will be doing 11.1, translations. Wow, Mrs. Oldham, why do you have a picture of Vector here? Mrs. Oldham, is that Vector from Despicable Me? Why, yes, it is. And we're going to be talking about vectors later. Hooray! Okay, so also with translations, as you noticed, this section is called translations. And no habla español or anything. I mean, I speak a little French, and that's about it. So, so translations are not like translating from one language into another. It's going to be something different. Okay, so a vector. We have that wonderful picture of vector, and in the movie he actually does say what a vector is, which I think is pretty cool. But a vector is a quantity that has both direction and magnitude, okay? Magnitude or size. So it has, I don't know how to describe it except it has a size, and it does depend on which way it's pointing, okay? So size, so direction and magnitude, and is represented in the coordinate plane by an arrow drawn from one point to another, like a ray, except when we say we have vector AB, we have an arrow on top, but it looks like that. It doesn't have the last little on it. Okay, so that is what a vector will look like when you're talking about specific ones. Okay, so let's look at this. Right here we have vector PQ with the almost finished arrow on top. Okay, it's not QP, it's PQ, because right here, this is our initial point. Okay, and it starts here and goes up to here. This is our terminal point. Terminal meaning ending. Okay, and it's said, it's written like this, but when we say it, it's vector PQ. So that's how we say it. All right, this piece right here, you'll notice that it's 5 units, and it's going to the right. This is your horizontal component. And this right here is your vertical component. And you know what, I'm going to actually, just right now, just say that if you don't have graph paper, you're going to want it for this lesson. So get it out if you have it. If you don't, you might want to print some out from the internet, or if you can't do that, then, I don't know, make yourself little grids and stuff. Because we are going to be doing some graphing later. Okay, so I'm just making sure I have everything. So horizontal component is 5. And our vertical component, 3 units up, so it's positive, is 3. And when we write this in component form, so the component form of PQ is it's going to look like a coordinate. Since this is moving along, it looks like it would be moving along the x-axis. That's going to be my x coordinate. And this looks like it's moving up the y-axis, so this will be my y-coordinate. But instead of brackets, we have these pointy things. Honestly, I'm not 100% sure what they're called. Maybe I ought to look that up. Anyway, so this is what the component form of vector PQ is 5, 3. And the way I kind of think about vectors is that they're described by the horizontal and the vertical components. And so the way I think of it, because you're connecting the beginning to the end, is that say you have a rock right here, and you're pushing it, and you've got two people pushing it. One of them is going this direction, and one of them wants to push it this direction. Well, the person pushing it this way, in this case, is a little bit stronger than the person pushing it this way. So say we have this person over here is pushing it this way, and this person right here is pushing it that way. If they both push at the same time, that rock is going to move along that line. And that's what I think of when I think of vectors in their component form. Okay, so